Hi guys, very good evening to everyone. Today we will discuss about a PCA. PCA means the principal component analysis. What is the meaning of PCA? A principal, a principal component analysis. The principal component analysis. So the PCA actually unsupervised machine learning algorithm. Okay, PCA is part of unsupervised ML. Unsupervised ML means there is no any kind of output column. There is no any kind of what? Output columns. Okay. So the thing is that why PCA? The thing is that why PCA? Using a PCA, what will convert? We will convert or we will transform a higher dimensional data, a higher dimensional data to a lower dimensional data. To a lower dimensional data. So why? Actually, what is the reason behind it? Why we will transform the higher dimensional data to lower dimensional data? So the first reason is that if we have the higher dimensional data, if we have higher dimension data, it is very difficult to visualize. It is very difficult to visualize. Why guys it is very difficult to visualize? Consider our data. Consider our data. In this particular data, in this particular data set, you have 10 columns. You have what? You have 10 columns. No, what you want to do? You want to visualize 10 columns. You want to plot 10 columns. Is it possible, guys? You want to plot 10 columns. Is it possible, guys? It is not possible. We can see up to 3D. We can see up to 3D. We can manage up to 3D. But beyond 3D, we can't see. Beyond 3D, we can't see. So I want to visible the 10 columns data. So it is not at all visible. Okay. What is the second reason, guys? The ML process will be slow. The ML process will be slow. Consider you have unnecessary 14 columns is there. You have unnecessary 14 columns is there. But the 14 columns is exactly not required. So I'm trying to fit using a 14 columns. The entire ML pipeline will be slow. So we have to reduce, if it is possible, then we have to reduce the 14 to like 7. Okay. I think you understood why, what is the reason behind it. So now the PCA, what it will do, I have already told, it will transform the higher dimensional data to the lower dimensional data. So I want to reduce what? I want to reduce the dimension. I want to reduce the dimension. So for that, we have two things. Okay. One is the feature selection. One is what, guys? One is the feature selection. I want to reduce the dimension. For that, two process we have to follow. One is the feature selection. Another one is the what? Another one is the feature extraction. Another one is the feature extraction. Now the thing is that if I'll go for a feature selection, I am taking one example. Like I want to predict the house price. What I want to predict? I want to predict the house price. So the thing is that in that house price prediction, I have a number of rooms. Okay. I have some columns like that. The number of grocery, the number of grocery market near your house, and based on that I want to predict what, guys? I want to predict the price. Okay, so here if you consider, the number of grocery market is not that much impactful column. Okay, the number of rooms, it's actually depends on the house price prediction, but the number of grocery market, it is not that much impactful. So what we will do, we have to select the one feature. Okay, we have to select the one feature. If we will do these things mathematically, so we have to calculate the variance. For calculating that variance, we have to plot what? The scatter plot. Let me open a Paint. Okay, here there is what? There is the rooms. Okay, there is the number of rooms, and there is the number of what? Na grocery shop. Now I want to draw a scatter plot, and after plotting a scatter plot, I want to check the data distribution. I want to check what? The data distribution. So if I want to check the data distribution, so what will happen? Now, where the room is there, the variance or the data distribution will be high there. But when the grocery shop is there, the data distribution is low there compared to a room. So in that way, I can select one feature. That is what? That is the room. So room we have to consider, and grocery we have to what? Delete. Okay. The thing is that in this case we can easily understand. But the thing is that now, instead of the room and grocery market, you have a room, washroom, and based on that, you want to predict what? The house price. So here you have room, and instead of grocery, you have what? Now washroom. Now the data distribution of the room and washroom, it will be same. Okay, there is no any kind of changes. So what we'll do, we can drop any columns? No. If we'll do these things using a feature selection, we can't drop one columns because two things are most important: the size of room and the size of washroom. So what we'll do, we can't go for a feature selection that time. Okay, we can't go. Then we'll go for what? We'll go for a feature extraction. So if we'll go for a feature extraction, there is a technique of PCA. Okay, one feature extraction technique is what? The PCA. So instead of the room and washroom, we can change the columns. We can write size. In that size, we have both the room and as well as the washroom. And previously it was what, guys? Previously it was a 2D data, two-dimensional data. I have not changed anything. The data is same only. But instead of that room and washroom, I have taken the total size of room and washroom. And my updated column name is the size. Okay. So in that way, I can convert 2D data or any dimensional data to 1D data. Okay. Or 10 dimensional data to 2D data means I want to reduce the dimension. It can be 3D, it can be 2D. I want to reduce the dimension. Here previously it was the 2D. I have converted to 2D. Previously it was 2D. I have converted to 1D. Got it, guys? So in that way you have to transform the higher dimensional to lower dimensional. So what is the benefit of that? We can see, we can easily visualize that. And the second thing is that the machine learning pipeline will be fast. It will be not that much slow. Okay. And here some mathematical intuition is there. We have to calculate our covariance. We have to calculate the eigen value. Based on that, we can tell the principal component. Okay. So that is all about the PCA, principal component analysis. Hope you enjoy and like this video. Bye bye, guys.